Hey there, welcome to this lesson video. In this video we're going to be talking about six trig functions. We're used to, the three, sine, cosine, and tangent, but there are three others that we're going to look at, cosecant, secant, and cotangent. So first, we're used to seeing the abbreviations, basically because on your calculators, the sine, we're used to seeing sin, okay, meaning the sine. We're used to seeing the cosine, abbreviated as COS, and then we're used to seeing tangent, obviously TAN, okay? Three additional trig functions, I wanted to type them out so you could see what they were: cosecant, secant, and cotangent. Cosecant, you're going to see as abbreviation CSC. Secant will be abbreviated as SEC, and cotangent COT. Okay, so these are the six trig functions. Like I said, we're used to the first three. These last three are new for us though. So let's see, what do we got? In a previous video, we talked about, a point on a circle and finding the sine, cosine, and tangent by the reference triangle made from that point. So we're used to, this being theta, and this would be our opposite side in respect to theta. The side on the axis would be adjacent, and then this would be our hypotenuse. Okay, and so if you think about that one should be an R. Sorry about that. If you think about this being the x value, the height of the triangle being the y value, and the hypotenuse being r, using the Pythagorean theorem like we did in a previous video to find r, we get these sine value, y over r, cosine, a over h, so x over r, tangent, o over a, y over r. But here's how cosecant, secant, and cotangent work. Cosecant is just the sine value flipped, so r over y, the hypotenuse over the opposite. Secant is cosine flipped, which is r over x, so the hypotenuse over the adjacent. And then tangent is obviously our cotangent. Sorry, cotangent is our tangent flipped. I was saying it backwards. So that would be the adjacent over the opposite. Okay, so I think it's easy to remember that cotangent obviously is the tangent flipped, but be careful. I remember when I was learning this for the first time, I always wanted sine and secant to go together. I always wanted secant to be the opposite of sine because they both started with an S. That's just how my brain processed it, but that's wrong. It's actually the S's and C's. So sine with cosecant, cosine with secant. Okay, so be careful. Make sure you don't make the same mistake that I did. But here's our first question. It says, if the sine of theta is negative 4 over 5 and cosine is 3 over 5, list the four other trig functions. Now there's no picture, I don't have a reference triangle. What the heck? How am I supposed to be able to find the four other trig functions with just these two? Well, think about what sine tells you. Think about SOHCAHTOA. Okay, sine tells me the opposite over the hypotenuse. Cosine tells me the adjacent over hypotenuse. So I know OA and H, and that's really all I need to know. Tangent is O over A, so if I just use the numbers from the two sine functions I was given, O will be negative 4, and then A would be 3. So negative 4/3 would be the tangent value. Cosecant, remember, is the sine flipped, so H over O, so that would just simply be negative 5/4. Secant is cosine flipped, so that would be H over A, which would be 5/3. And cotangent is just my tangent flipped, so negative 3/4. And that's it. I was able to find the rest of the 4 trig functions. Relatively easy. Okay. Here's another example. Same things. I know sine and I know cosine. So what that means is I know the O value, the opposite side. I know the value of the hypotenuse. From cosine, I know the value of the adjacent side, and again the hypotenuse, which is the same as the previous. So then just run through my values. Tangent is O over A. Goodness. There we go. So negative 7 over negative 24. But hold up, 2 negatives make a positive. So it's just going to be positive 7 over 24. Cosecant, remember, is sine flipped. So it's going to be negative 25 over 7. Secant is cosine flipped. So again, negative fraction, 25 over 24. And then cotangent is just my tangent flipped. So it's just going to be positive 24 over 7. All right. And that's it for this one. I just have one more example to show you. It's a little different. This time it says if the sine of theta is negative 12 over 13, list the other 5 trig functions. And I'm given that this is in the 4th quadrant. Okay, so here's how this is going to work. Because I'm given sine, I know the opposite side is negative 12, and the hypotenuse is 13. And I'm in the 4th quadrant, so I'm somewhere here if I'm thinking about the coordinate plane. And if I think about drawing a reference triangle, okay, I don't know much about it. I don't know the angle. Let's see. There we go. Whoa, whoops. Here's what I do know. I know that the hypotenuse measures 13. And I know that theta, is always coming from the angle at the origin. And I know that the side opposite of theta measures negative 12. So it'd have to be this side, because these are in like the negative y values, if you think about the coordinate plane. So all I need to find is this missing side. So how do we find a missing side? Well, the Pythagorean theorem. Okay, so one of my legs is negative 12. So when I write out the Pythagorean theorem, I'm solving for b, which is one of the legs, more specifically the leg that I'm going to be missing, that I am missing. So let's see. Negative 12 squared, make sure you use parentheses. So it should turn out to be a positive 144. Plus b squared will equal 169. And then I want to think about getting b by itself. Goodness gracious. So to get b by itself, I'm going to have to subtract 144. Okay, so when we subtract 144 from both sides, we're going to get b by itself here, b squared by itself, and we're going to end up with b squared equaling 25 after that subtraction. Okay, and then I've got to get rid of the square by taking the square root. Let's see, so square root both sides, and so that I'm just going to be square root of 25 is simply going to be 5. Okay, so that means my missing side over here is a 5. Now, from theta, to find the other, 5 trig functions, I think we should label OAH. We know that this is the opposite side. Obviously, 13 was the hypotenuse. And the side on the axis, the 5, is going to be adjacent. And so cosine is A over H, so that's just going to give me 5/13. Tangent O/A is going to give me -12/5. Cosecant, remember, is sine flipped. So that's going to be H/O. So that's just going to be that guy flipped. So -13/12. Secant is going to be my cosine flip, so that's going to be 13/5. And cotangent is tangent flip, so -5/12. All right. I believe that's my last example, so let's make sure. Yeah. So that finishes it up for us on this one. Here's the next video that's coming up. Keep learning, have fun, and I will see you next time.